Mechatronics is this interdisciplinary engineering. It's the crossroads where all the different primary engineering disciplines meet. Over the course of a full semester, the students will start out from ground zero and do a lot of integration of mostly electrical and software engineering and controls engineering disciplines in, because it is taught in the mechanical engineering department. They will learn how to interface to different sensors, different actuators, control algorithms, the whole 9 yards.
So one of the things I really enjoyed about this course was that everything was hands-on. You know, you learned the theory, you know, literally on Tuesday, and by Thursday you had fully implemented a system utilizing that theory and putting it into practice.
I'm the kind of guy who learns by doing, not by you know, studying formulas and seeing what math comes out of it. In the end, it seemed to all build on each other, and you could use each piece individually, put them together to make something happen. And the Sumo is definitely one example of that.
The mini Sumo robot tournament is nothing more than essentially a robotic version of a Sumo tournament. The idea is to push your opponent outside of the ring before they push you outside of the ring.
Our strategy was to try and avoid being vulnerable as much as possible. So anytime we had our back or our side to our opponent, we knew that it was pretty easy for us to get pushed off. So we tried to steer away from that as much as possible.
For our Sumo project, we basically had this main function, and it called out a couple of other functions. And we went into each function test by test and made it, and actually, you know, designed it and then tested it in the real world as well as what the code is doing.
The overall goal of the class is to give these students some real hands-on practical experience building this all up into one whole complete system. So this is supposed to be a really good toolbox item for these students to take out into the real world.